This talk has the distinction of being the ugliest presentation here, as well as the most bleeding edge. And I will forewarn you that there are no basics in this talk. So we're just going to go through a refresher, and then we're going to jump straight into descriptor indexing, because that's how exciting it is. But the real reason is that it would probably take 2 hours to go through the full talk, and we had to cut some stuff. And the other thing is that the subtitle to this talk should be Descriptor Indexing. Here's all the words that you know in English. Here's what they mean in Vulkan. So there's a lot of overloaded words, so feel free to ask me what they mean specific to descriptor indexing at the end of the talk. And here's what we're going to cover. We'll do a brief overview of what the extension brings. We'll do a rush descriptors refresher. Then we'll go into some of the particulars in descriptor indexing, the highlights. And then we'll talk more about unbounded and then about non-uniform indexing. So a little history of why this extension came about is if you ask somebody like Tiago, like how many resources do you want to bind at one time, they'll tell you all of them. And that means that there's a lot of bindings that we need to access during shader runtime. And so through a lot of back and forth in the Kronos group, we finally came up with something that matches what you're pretty familiar with in DX. And so what descriptor indexing brings is it brings two features to Vulkan. The first one is to have extremely large sets or unbounded in DX talk, and the next one is, and it's orders of magnitude larger, like crazy large. And the one after that is dynamic non-uniform resource indexing. And this is mostly to make non-uniform resource index possible in HLSL. I don't know if you guys are using that yet, but it's been highly requested, and it looks like it's an awesome feature. I get to write a lot of test code for it, and so I know what it does. So descriptor indexing is an EXT extension, and EXT means that the IHVs are not required to implement this, but all the desktop IHVs have it, and I believe NVIDIA has it in their public driver now as of 3.97 or 39740, and AMD and Intel, it's coming soon, so that should be out hopefully soon. So EXT extensions may or may not become a part of the core, and what we do with these extensions is that we put them out so people can test them, use them, see how they apply to their app/engine design, and then provide us feedback. And your feedback definitely helps shape how this extension will become if it becomes part of the core or a KHR extension. And if it becomes a KHR extension, that means it's available all across the board. Okay, so descriptors refresher. So descriptors in Vulkan have both the descriptor counts that's available have both a per stage and a per set limit. We're going to focus on the per set limit in this talk. And descriptors are essentially collections of bindings described by set layouts. So in your shaders, you have a bunch of resources, textures, buffers, samples, etc. They're collected into a layout, and this layout determines what the set looks like. And allocation descriptor sets are allocated against pools. Pools have both a max set and a count limitation. And as far as updating goes, descriptors, updates happen outside of the command. Right now, updates must happen outside of the command record and execution. And you can update the descriptors in bulk, but they're specified individually. And we'll talk about that in just a minute. And the shader binding. So each descriptor binding maps to a single resource binding in the shader, including arrays. And this is slightly different from DX, and it's a little confusing if you look at the Spear V. Like the first time I looked at it, I freaked out. Okay, so updating. Here's what's possible now. So you can update as long as you're not in executable state. And executable state means that you are the state isn't pending, and pending means that the GPU might be working on it. And that was confusing to me when I first heard it too. But essentially, once you've bound the descriptor set inside the command buffer, you can't touch it. And if you do touch it, the behavior is undefined. And the two places that people often want to touch it are before it goes into queue submit and right after. You're not really sure what happens there. But once you're sure that the command has been processed, then you can start updating it again. And the next thing is arrayness. So here's a very simple shader, and it has an array of textures of 10. And And so it starts at T1 and it goes for 10. So T1 to 0, T10. And if you look at the FXT generation, it creates 10. It creates all 10 registers. But in Vulkan, it only creates one binding with an array of 10. And so if you're debugging and you have to go to the speed review level, you don't freak out. It's there. The array behavior is exactly the same. Okay. So sorry, I just covered this. All right. So descriptor indexing basics. All right. So applications can create much larger sets with VKEXT descriptor indexing. Shaders can index descriptors using dynamic non-uniform. You can query what the limits by using this struct when you're doing the get physical device properties, and you can also query the features, and you can toggle using. I'm sorry, these structs are incredibly long, and I can't even say them properly, so I'm not going to try. Thank you, spec writers. But essentially, these two right here, you pass them into either this one to create device and this one into get physical properties, and it tells you, or features, and it tells you what the device is capable of. So the other thing was I started to write out code snippets that I can show you guys, and by the time I got to the second slide, it was like 4 pages of code to get this thing set up. And so what I'll do is I'll write a sample, post it somewhere, and then tweet, you get at API Vulkan to tweet it out so that people can see it. Because I'm sure you don't want to hear me talk about 8 pages of code. I also don't want to talk about 8 pages of code. So you will, it will require the SDK 1.173, and your driver has to support VKEXT descriptor indexing. And as far as compiler support goes, DXT supports this now for HLSL, and GLSlang and ShaderC support for GLSL. I'm not sure if GLSlang is planning to add it or not. You can acquire that from the GitHub issue.
Hi, I've got one question already.
Yes.
Can you define the phrase dynamic non-uniform?
Yes, I can. That's probably a typo. I should have probably just typed non-uniform. But dynamic non-uniform just means that each invocation of the lane, going back to Daniel's talk, can be arbitrary. So when it's dynamic uniform, all the value is the same across all the invocations. Does that make sense? Okay. So that's what I meant by these words are overloaded. Okay. All right. So descriptor indexing, the limits in organizations change just a bit. You get there are still limits imposed by the driver. They're just ridiculously big, and the minimum limit per set in the spec is 500,000. And so that means that you can reference up to 500,000 resources inside your shader. Whether it's a good idea or not, we'll leave that up to the designers. And here's how much they increase for certain IHVs. I wasn't sure if I could quote names, so I anonymized them a little bit. So the first IHV, the sample images went from 90,000 to 1 million, and the samplers went from 4,000 to 1 million. And storage buffers went from 90,000 to 1 million as well. And on this other IHV, if you're familiar with this, you probably know who this is. It was it's a few thousand shy of 4 billion, and it went to the full 2 to the 32nd minus 1. So Nguyen maxes the limit. And the other thing about the arrays at the shader level is that they can be unbounded. So if you're looking at this extension in the spec, it won't use unbounded except for maybe 1 or 2 sentences. Variable size or variable count is what the Vulkan version of this is called. Even though you activate this extension, you don't automatically get, not all things are unbounded. You have to tell it that, hey, I want this binding to be unbounded. And we'll get into the specifics of more of this in just a little bit. But as far as updating goes, a few things have changed. So you can now update after you bind the command buffer. And the command buffer will use the most recent versions of what you updated with. You can also update in any command buffer that is in pending state. That means it's executed on the GPU, as long as that descriptor is not in use. There is quite a bit of setup, which is hopefully will be demonstrated to the code. I won't walk you through that, but it's about a page of code. Not to say that this should deter you from using Vulkan, because it's equally as long in DirectX as well. The other thing about being able to bind, to update after binding, is that your bindings, your sets, and your pools have to be created with a special flag. But if you're just using update while pending, then it's just one flag, and you do that during the descriptor creation time. And so here's what the new version of updating looks like. And obviously you can update after you bound, and you can update even after you submit, as long as you know that the descriptors are not in use. All right. So we talked about being able to update descriptors while they're not in use. And so here's a more specific example of it. So let's say you have a reference in a shader that has 65,000 entries, or 65K entries. And there's 8K objects, and each one of them references 8 textures. So your bound is open-ended on the upper. So it's object ID times 8 and object ID times 8 plus 8. So each object would reference a texture, one of the 8 textures in this range. And the way that this hypothetical engine happens to work is that everything is deferred until it comes in the scene. So as you're moving throughout the level, things get loaded, and your PSOs are created, your descriptors are created, etc. And so this particular binding is always partially populated until you've seen everything at least one time. And so this is all okay now. Whereas before, if you try to do this, either validation will give you a warning, or you'll just crash, or the driver will do something completely funny. But there is a flag that you need to put when you're creating the descriptor binding, and you want to tell it, hey, this descriptor binding, I want it to be partially bound. All right, so on unbounded. So a quick recap from earlier. The variables, again, we call it variable size in Vulkan. And it requires this really long flag to make it work, and I hope you have autocomplete on in your IDE. I just copy and paste from the spec. And so the other thing to note is that there's still limits, so you still have to specify the pool count, but the descriptor count becomes the upper bound of what bindings are possible. And I haven't tried creating 4 gigs worth or 4 billion descriptors, and I'm not entirely sure what will happen if you tried that. But the minimum definitely works. So the other thing is that there's a slight restriction on which of the descriptor bindings can be unbounded or variable size, and it has to be the last entry in your set. And so there's a slight difference between this and how it works in DX. In DX, there's a namespacing on all the resource types, so you can be unbounded on any of these, and it won't care too much, assuming your IHV supports it. Vulkan only lets you do it on the last one. So if when you're designing how you want resources to be indexed, whether dynamically or not, keep this in mind. And this is the part about non-uniform indexing. So we established earlier that the array indexing works the same in HLCell for Vulkan and DirectX. The lower level mechanics notwithstanding. And there's some slight differences in the unbounded behavior between Vulkan and DirectX, and hopefully having large sets can help you alleviate this. So if you want to do non-uniform resource indexing, you will need to enable the feature when you're creating the device, because otherwise it won't work. And each one of the fields, there's each one of the resource types has its own individual field to be toggled. So you can uniform buffers, storage buffers, textile buffers, etc. They all have individual flags that you need to turn on. So maybe the best thing to do is just grab whatever you see on your GPU, look at it, and decide like that's the best thing. And make sure that you make the decision to turn those on. Or error out if you are using a feature in your shader that isn't supported by the GPU. And so here's a And so non-uniform resource index in HLSL, it works it works the exact same way in DirectX as it does in Vulkan, in Vulkan as it does in DirectX, and it's currently only supported in DXE. So here's a very pathological case of what it would look like. I had printed out the spear V for this, and it was actually a lot longer than I thought it would be, and it also looked completely incomprehensible by any reasonable person, so I'll save you from it. But, so here's some things that you should take away from this talk for this amazing extension. First of all, is you can have much larger descriptor sets, and the updating of these descriptors have changed, become a lot more flexible, more akin to what you're used to in other APIs. And non-uniform resource indexing. And if you're not using that, those are very specific cases of when you would want to use that, and you may not need to use that if you don't have a case where you need to index non-uniformly. Are there any questions so far? Yes.
Is there a performance penalty in updating the descriptor sets after the one that was
I can't be for certain that it won't happen across the board, but technically there shouldn't be because it hasn't started execution yet. So if you bind and you haven't submitted yet, I don't see a reason why it would be. But depending on the implementation, there may be some overhead, but it may be negligible. Any other questions?
Hi. What is the use case of the descriptor indexing? What is why do we would need like
Okay. So let's say you
65K of textures?
Well, I can't tell you why you would need 65K of textures, but let's say you design a game engine, and because of the crazy high refresh monitors, now you want to render 6 frames in flight as opposed to 2 frames in flight, right? And each one of these has to carry different resources. And so, if you have let's say you have some shader that uses 300 or 500 resources per call, and you want to put this, you want to use this shader across these multiple frames. And obviously, if you want to render objects, you need to segment which frame maps to which level of which bin of resources. So there's not a pathological case of why you would want to use this necessarily. If you have a very high requirement for the types of resources or the number of resources that you want to access at runtime, this is what this enables. And also, if you have shaders in like compute shaders or picture shaders where you need to reference resources non-uniformly, that means that it's not the same across the entire the entire wave. Then you would need non-uniform resource index. Otherwise, the compiler will still compile the code, but it has unexpected behavior. Like you'll get like crazy weird edges, or it just won't render correctly at all. Does that answer your question? Okay. If there's any terms that I've used that are confusing while writing this thing, I realize that there's a lot of them, so I can clarify anything if anybody's interested.
I just wanted to add that a common case for us is basically batching multiple draw calls. So you basically, instead of switching pipeline states, often if you have the same shader and the only thing that changes is the resources, you can actually batch those draw calls and then index them.
Okay. So all the questions? Okay, so first of all, so Vulkan with this extension allows you to have much larger descriptor sets and allows you to have more flexible updates. And so this means like updating the descriptors are quite a bit of work in Vulkan, right? So Marcus is going to talk to us about an extension that reduces some of the pressure and makes it easier to update bulk resources in Vulkan.